Today's episode of Filmmaker U is brought to you by our sponsors OWC. Go to owcdigital.com for all your filmmaking and computer needs. And it's also brought to you by our other sponsors, AJA. Make sure to check out aja.com so that you can see how they can help you in your post-production needs.
Hi, I'm Gordon Burkell from Filmmaker U. At Filmmaker U, we create courses for film professionals to deepen and diversify your existing skill set. You can learn more at filmmakeru.com, or of course, follow us on Twitter at filmmaker_u. Every week, we interview film professionals to discuss their work, and this week I'm joined by Mark Hudgins, Imagine Products COO and lead engineer. Welcome to the show, Mark.
Thanks for having me.
I guess my first question for you is, for those who aren't aware of Imagine, what is it that you guys do? What are your products? What should we know about you?
Well, we are a software manufacturer that specializes in making workflow applications for the media and entertainment industry. Probably our most popular application that folks are aware of is called Shotput Pro, which is geared towards getting your camera originals off of the camera and to multiple destinations as quickly and as securely as possible.
So now, I guess because I don't work on set much, but I have dealt with a lot of DITs. And so one of the big things, like you said, is security. So how do you guys at Shotput tackle security and protecting our files?
So the main mechanism used to sort of guarantee that your source files match your copy files is using checksumming technology. So basically what a checksum is, if you're unaware, is it's a string representation that's sort of an aggregate value for the entire file. Basically, you take all the bytes in the file, you run them through an algorithm, and it spits out a value. That's essentially what checksumming does. So what you want to do is you've got to guarantee that your source matches your destination. Now, in the old days, when everything was film-based, you could maybe afford to lose some data somewhere along the way, and you could always go back to your film originals and start all over. Now that everything's file-based, you're recording to these mags, and they're popping them out of the camera, getting the data off, reformatting them, and popping them back in the camera to use them over and over again. So if several hours after the shoot's done, if you realize, some of my files are messed up, it's gone. And we have had several horror stories of people just, losing very, very valuable footage that they either have to go back and reshoot, or if it's with somebody, important like the President of the United States or the Pope or somebody like that, there's no recreating that data or those shoots. So you've got to be absolutely sure that what you've copied matches what the source was, because there's just no going back once those originals are gone.
So really, like the point that everyone should be stressed at is, once they've finished the shot, they got to walk the drive over to your system and back it up right away.
That's right.
That's the only point of failure once we get to you guys.
Right. That's the main point of failure is, making sure that those bytes are streaming through the cables, through the computer to the output drives, and that everything's byte identical after the replication.
And what do you guys recommend because you're duplicating the file? So like, what do you guys recommend for backups? Like, do you have rules or guidelines for our users?
Yeah. So typically what folks use on set, it's all about speed on the set, right? So a lot of our users are going to be using the absolute fastest drives possible. You got a lot of solid states, NVMe, I believe that's the acronym, to get you the fastest throughput you can. But what we recommend is, when you've got a moment to take a breath and really think about security, there's a very popular, it's called the 3-2-1 rule for data security and for backup management. The 3 stands for, you want 3 copies. You want your original copy and 2 duplicates of that copy. So that gives you plenty of security that if there's a problem with one of the backups, like for instance, if a drive starts going bad, that if that drive goes bad and everything that's on that drive is hosed, you've still got 2 other copies to go back to and sort of recover. The two stands for two different media types. And types of media are, hard drives, LTO tapes, network storage devices, even the cloud these days can be counted as another medium. The main point of that rule is you really want to avoid, and this is a situation I've seen and heard about, getting a bad batch of drives. Like I was on Amazon the other day and I scooped up some really fast, really cheap drives. And they came in and they're all from the same batch, which is fine for what I'm doing. But I'm sure a lot of like your listeners have heard stories about, or even if you can read it in the news that they'll publish, like, oh, a batch of drives was bad, don't use them. Well, if you recorded or you recorded to or copied to a bunch of drives that were all from the same batch and that batch was bad, then it doesn't matter if you made 3 copies, 10 copies, or 20 copies. They're all gone because that batch was bad. So that's what the essence of that two value is, just to make sure that you're diversifying what you're storing your footage on. Again, in case worst case scenario happens, you have some way to go back and recover. And then of course one stands for at least one copy off-site, which in the old days typically meant throw it on an LTO drive or even a couple of solid state drives and put it in a vault somewhere or in a safe box, so that if a hurricane comes ripping through and destroys your production facility, that you still have something to go back to. It's been a lot easier now that cloud has gained traction, has become affordable. That's a really great way to have your offsite storage if you can A, afford it, and B, if it fits with your security requirements.
Now we have, because we have a lot of students who watch these videos. So one of the things you talked about was speed, and you were saying that a lot of your users would be using very high-end, fast computers. But when I was on your site, I was reading something that was talking about how it was, the software was fast and efficient. So how do you, for transferring, so how does the software help enhance the speed transfer process?
Right. So like one thing, if you're doing like a Windows or Mac, Finder or it's Explorer on Windows, the common thought for someone who doesn't do this on a daily basis is, well, why would I use software to do this? I can just drag and drop. Well, for a lot of various reasons, that's a bad idea, mainly from a security standpoint, which we already touched upon. But there's also a speed issue that some of these backups can take quite a while. And if you start queuing up replication jobs, if you start doing multiple drag and drops, Finder and Explorer tend to slow down quite a bit because they don't really have anything built in to sort of intelligently copy these things so that I'm not jamming up all of my resources. That's one thing our Shotput app does, is that as jobs are a lot queued up, we use intelligence built into the software to have that flow occur at an optimal rate and queue up jobs to occur in an optimal fashion, so you're not degrading performance by throwing too much at the computer.
I think you might have just gotten a sale with me because I do a ton of transfers of terabytes, and I'm just like, oh, well, I guess I'll see it in a day or two.
Oh yeah, we'll send you some software and you can give it a run through.
Okay.
See if it helps you out.
Well, and like some of the students might be aware of like the points of failure, but what are some points of failure that you've seen, that you've heard of from sets?
The big ones, especially with these fast drives, I have yet to find one that doesn't just start burning up after about 30 seconds of high usage. Like they move really, really fast, but with that speed comes a lot of heat. And one thing that we've had to rig up here in the office is I bought some like calf sleeves that are meant to compress when you've got sore calves, that I actually put those in the freezer and put my drives on that and then flip it over to keep the drives nice and cool as they're being as they're doing their job, and to keep the temperature down. Because once that temperature starts to rise, the throughput rate drops considerably. And of course, when you're heating up your drives, the more or the higher the temperature gets, the more damage it does to the drive. So it's really going to shorten the lifespan of your drives if you don't keep those things at a reasonable temperature. And one thing that folks don't realize is when the heat rises, you can start getting incorrect or byte transfer. And this can be a critical problem when it comes to, even with checksumming. So what checksumming does is it calculates the value for the bytes you read and then calculates the value of the bytes at the destination and makes sure that they're equivalent. Well, if the bytes flowing from an overheating drive come through and they're incorrect, a standard checksum is not going to catch that problem. It's essentially a garbage in, garbage out problem. Now, in Shotput, we do have the ability to do basically what we call a source integrity verification, where we reread the source once again and calculate a value on that source. So basically, if you reread the source or read the source twice and get the same value, you know that you don't have a garbage in, garbage out situation, because even when a drive is overheating, the odds of the same bytes being corrupted the second time through due to an overheat problem is minuscule, especially when you're thinking about, how many bytes are in a 100 or 50 gig file. So
yeah, okay.
The other ones are things like older drives. If you write to a drive and they've been used for a long time and they're starting to degrade, those can go bad and you can lose data that way. Old cables or cheap cables can be another source of problems that, after a lot of use and wear and tear, folding them up, pulling them out, just running them through the ringer, they're gonna degrade over time. So you want to make sure that you're not using old equipment when you're on set doing your data management. Those are mainly the main sources of problems that we've encountered with our customers, telling us that these are their pitfalls and that our software has saved them quite a few times. Because when our software starts telling you that there's a problem, that's when you need to take a look and say, okay, why? If it's not the software, what is the problem? And the software can help identify you where you might be going a little bit astray in your flow.
So what you're saying is my Firewire 400 from 2000, I shouldn't be trusting with my data anymore.
You might want to reevaluate what components you're using in your process.
On your site, it also referred to something like a collision space, like having a robust collision space. What is that? What do you mean by that?
So these checksum algorithms each have their own what they call collision space. And what a collision space is how often would two different, let's say, blobs of bytes or by a group of bytes, and that's what a file is, a group of bytes. How likely would it be that two different groups of bytes give you the same hash value? And as you can imagine, that's a very dangerous thing, because these hash values are supposed to be, if this file has this hash value and that file has the same hash value, well, they're equivalent. So if your collision space isn't, robust enough, there's the possibility that file A and file B will give you the same value, even though their bytes are different. So that's why you want to choose a hashing algorithm that makes that possibility incredibly small, the order of 1 in a 500 billion or 1 in a trillion, that sort of magnitude. I'd have to go back and look at the specs on all the different algorithms, but the ones that we include in our apps are fairly robust in that they're not, there's a million other things that could go wrong before you're going to have two different files give you the same checksum value.
So, because there's a lot of data being transferred, is there some kind of speed versus security? Do you find that you can speed things up, but you lose security, or vice versa, you'd slow things down? And
so typically the most robust in terms of security, and in terms of a checksum, when you're talking about security, you're talking about that collision space. The SHA-2 512 has been, forever. What I would say is probably the most robust and the largest security, or the largest collision avoidance. But it takes quite a bit to generate one of those values. It'll be your bottleneck in your replication process if you choose that hash algorithm. There was a concerted effort that people saw that most of these checksums were generated from a cryptography standpoint. They're meant to, that's sort of their background, that they were built for cryptographic reasons. And they're just sort of used on files because, it gave us what we needed. There was a group that developed the XX hash algorithm. Those are non-cryptographic hash algorithms. And they were designed to be used on files, which is exactly what we need. We need something to verify the integrity of files. So though that algorithm set, and there's 3 of them that we include, there are 2 64-bit hash algorithms and 1 128-bit hash algorithms. And since they're geared to work on files, they can generate the checksum value super, super fast. So fast that the checksumming process doesn't become the bottleneck anymore. So they're fast, and they also have a very robust collision space. So it's sort of like a happy marriage between security and speed with these algorithms. And that's what we typically recommend our users use when they're doing their replications or their copies.
So does this have to do, and again, this is just from my research, so I apologize for my ignorance of this, but does this have to do with the ASC media hash list? Yeah,
so that sort of goes, the ASC does make use of checksum algorithms to sort of, for the keeping track of it if files are equivalent. But the ASC was sort of an effort to address a larger problem, that not just having, it's nice to have checksum values, but what they really needed, they wanted to make the process of transferring data standardized. That sort of the goal is that every time that you transfer a file, that there should be some sort of record of what the value of that file was at that given point in time. And that's more or less what the ASC MHL does. It creates what we call a manifest file, that every time that you copy or move a file, that the checksum value of that file is recomputed and compared against what it was previously at the previous point in the process. And so if you move that file 10 times, you're going to have 10 records of what that file was at that given time. And ideally, if everything goes well, all those values will match. Now, if they don't, you have a better idea of where to go back to figure out where things went wrong and recover. So it gives you a nice long paper trail of what the value of your files were at any given time, so you can go back and make things right when they go wrong. It's much easier to do that. So that is the primary goal, at least in my opinion, of the ASC MHL. The other benefit it gives you is that it gives you standardization in terms of how do you record these values. Now, every organization has their own internal specs about how do you, make a manifest and keep track of your data and what the values are. That's fine if you're working within HBO or within Netflix or, within even a smaller production studio. But now with, everybody seems to be on cloud now and collaborating. How do you guarantee that flow when your data leaves your organization and goes into somebody else's organization? Before the ASC MHL, that was kind of a cumbersome effort, but if both the source, where the data is coming from and where it's going, if they both adopt this standard, there's really no issue in transferring that data from one organization to another. So that's another benefit of this standard.
Now, you deal with archiving. We've mentioned or talked a bit about archiving, but what are your recommendations, especially for people just entering the industry or who might not have the same budgets as a Netflix, for archiving their projects?
Yeah, what a lot of folks do, and even larger organizations still make use of the LTO tapes. In terms of cost per byte, it's going to be the cheapest the cheapest option you can find. And these tapes, I think they're up to, I'd have to look at the specs, 16 or so terabytes, maybe even more now. And you can get that for a couple $100. So, well, with that, you'll also need a deck, and the decks run between $4 or $5 grand. So out of the box, you can get a very large archival system for under 10 grand. So that price point is very attractive to folks that don't have the budget to throw everything up on Amazon Glacier or have their own in-house, rack servers and, all these things to make sure that your data lasts for the next 30 years and is accessible for the next 30 years. So it's still very, very a popular way to do long-term storages on LTO tapes. Now, there's been a big push. I mean, IBM's been at the head of it. There's this paradigm, I guess I'll call it. It's called LTFS. It's called Linear Tape File System. Back in the old days, everybody used tar files, and you had to have a proprietary way of wrapping those files and retrieving those files. IBM decided that it was better if they opened it up. And that's kind of what LTFS is. It's an open way to mount tapes on drives and have them show up on your computer, whether it's Windows, whether it's Linux, or whether it's Mac OS. So that's what we make a software called MyLTO that sort of harnesses that openness and writes to the tapes and gets data to your tapes for long-term archival. And the benefit of that is, since it's open, while we would love for you to use our software for the next 30 years, chances are when you go to retrieve want to retrieve that information 10, 15, 20 years from now, you might have trouble finding a copy of MyLTO from 2022 to get that done. Again, since it's open, you can pretty much use any LTFS compliant software or the command line, if you're savvy enough, to get your data. So you're not locked in to any particular software solution when it comes to accessing your archive data in the future.
Okay, I have one last question for you. And this is just a fun question to wrap things up. What would you say is your favorite guilty pleasure film or TV show to watch?
Guilty pleasure film. Well, I'll say this. My favorite guilty pleasure TV show, without a doubt, and my wife rolls her eyes at me every time I turn it on, is Reno 911.
Oh, it's a great show.
I can't get enough of dangling the crew. So yeah, that is definitely, and I'm watching it right now on probably watch it when I get home, turn on HBO and watch me some Reno 911.
Fantastic. Well, thank you so much for letting me interview you today.
Thank you for having me. Hopefully it was your students learned a thing or two.
Oh, I'm sure they did. I learned a thing or two, so I'm good. That's it for this week, everyone. Make sure to check us out at filmmakeru.com, or of course follow us on Twitter at filmmaker_u. I'm Gordon Burkell. Thanks for watching.
Today's episode of Filmmaker U is brought to you by our sponsors OWC. Go to owcdigital.com for all your filmmaking and computer needs. And it's also brought to you by our other sponsors, AJA. Make sure to check out aja.com so that you can see how they can help you in your post-production needs.